Hello, welcome to my channel. Hit the like and subscribe button. Today we're going to be learning about limiting factors in chemistry, and we're going to be able to explain the effect of limiting the quantity of a reactant on the amount of products in terms of moles or masses in grams. So we've discussed last lesson about the ratios that chemical reactions occur in. So here we've got magnesium plus 2 hydrochloric acid, 2 moles of hydrochloric acid gives you 1 mole of magnesium chloride and 1 mole of hydrogen. So the ratio goes 1 to 2 to 1 to 1. So in this example, how many moles of hydrochloric acid would be needed to react with 2 moles of magnesium? Right, so if I actually had 2 moles here, I would then have 4 moles here. The ratio would go 2, 4, then producing 2 and 2. So how many moles of magnesium would be needed to react with 6 moles of hydrochloric acid? So if I had 6 moles of hydrochloric acid, the ratio would go 1 to 2, so it would go therefore backwards. I'd divide it by 2, so that would be 6, that would be 3. So it would go 3, 6, 3, 3. Alright, so this is the facts you need to know about excess reactants. In order to make sure a particular reactant completely reacts, it's common to add the other reactant in excess. In other words, to add more than's actually needed. Okay, earlier in the course when making soluble salts, we reacted copper oxide with sulfuric acid. We added the copper oxide until no more would dissolve. In other words, we added the copper oxide to excess. Now, because earlier in the course you were in lockdown, we will do this experiment. I will try and book this in as soon as you get back into school, and we can actually have a go again at reacting copper oxide with sulfuric acid to make a soluble salt, and we will add the copper oxide in excess to make sure that all the sulfuric acid is reacted away, and you've got more copper oxide than sulfuric acid, so almost more copper oxide than's actually needed. Okay, so that was talking about something being added in excess. So the other thing that isn't in excess is called the limiting factor. So if one reactant is added in excess, we say the other reactant is the limiting factor. So in that copper oxide and sulfuric acid experiment, the sulfuric acid would be the limiting factor. And the limiting factor is a substance that determines how much of the product can be made, because it limits the amount of product. The rest of this PowerPoint you can go through. It goes through talking about doing in a table form, calculating which is in excess and which is the limiting factor. But actually I want to just use the handouts that I've emailed, and instead I want to talk you through them, hopefully like this. Okay, so this says, in each example, one of the reactants is in excess. Work out how many moles of the products are formed in each case. And then we've got a series of reactions. So this is the handout limiting reagents 1. And there is 7 questions. So I'm just going to take you through a few and just calculating what is in excess and what is limiting. Okay. So when I'm looking at a reaction like this, my start off point is to think, right, what's my ratio of reaction going here? So I've got 1 mole here reacting with 1 mole here to form 1 mole here. So 1 mole of calcium oxide will react with 1 mole of water to form 1 mole of calcium hydroxide. So if, for instance, in my reaction, I actually, in the beaker, I put 2 mole of calcium oxide and 3 mole of water, one of these reactants is going to be in excess and one of them is going to limit the reaction. So if my ratio is normally 1 to 1, if I have 2 mole here, it only needs to react with 2 mole. So it only needs 2 mole, and you would end up forming 2 mole. So which one is limiting and which one is in excess? Well, this one is in excess, so I would probably write actually excess, and this one is limiting, so I'm going to put limiting. Okay, so then I'll know that 2 moles would react with 2 moles and it would form 2 moles. Okay, so the answer for 1A is 2 moles. How many moles of products are formed? In this instance, 2. One of the reactants is in excess. I've also worked that out here. It was, in this instance, water was in excess. Okay, so same equation. If I wanted to react, put in my beaker 10 mole of calcium oxide and 8 mole of water, which one is in excess and how many moles of product would I end up with? Well, I know my ratio is 1 to 1 to 1. So if I have 10 moles of calcium oxide, I'm going to need to react it with 10 moles of water to make 10 moles of calcium hydroxide. But I've only got 8 moles of water. So that's the one that's limiting. So working backwards, if that's limiting, that one must be in excess. And I actually only need 8 mole of that. And the ratio would be 8 mole of that would react with 8 mole of that to form 8 moles of calcium hydroxide. So the answer is 8 moles. All right, so C, 0.4 moles of calcium oxide in my beaker with 0.5 moles of water. So the ratio is 1 to 1 to 1, I know that. So if I had 0.4 moles, I'd actually only need to react it with 0.4 moles. All I need is 0.4 moles. So I've actually got 0.5, so that's the one that's in excess. This one is limiting. So therefore my reaction would actually going to be 0.4 moles of calcium oxide is going to react with 0.4 moles of water to form 0.4 moles of calcium hydroxide. All right, if you feel that you've got that now, then you can just pause the video and complete the rest at your own pace. If you actually are still a little bit confused, I'm going to talk through the next one, which is calcium reacting with oxygen to form calcium oxide. So my ratio here is 2 moles of calcium will react with 1 mole of oxygen, that's a 1 not a 2, to form 2 moles of calcium oxide. So which one is the reactant in excess? 2 moles here, 2 moles here, whereas actually I only need to have 2 moles reacting with 1 mole. So this is the one that's in excess. So I only need 1 mole here. However, if I had 2 moles here, I would actually need to have 4 moles here. So here is my limiting, here is my excess. So because this is the limiting one, I can only ever make 2 moles. And I'm actually going to have 1 mole of excess oxygen. All right, so here we have 10 mole of calcium reacting with 2 moles of oxygen. How much am I going to make? So already I can see that that's a lot of calcium I've got there. So if I've got 2 moles of oxygen reacting and the ratio is 2 to 1, I only need 4 mole of that. So this one is way in excess. And this one is limiting. And the ratio goes 2 to 1 to 2. So to transfer that, it would go 4 moles would react with 2 moles to produce 4 moles of calcium oxide. Okay, so the last one on this one here. Remember my ratio is 2 to 1 to 2. So 0.5 moles and 0.2 moles in my beaker. How much am I going to make and what's in excess and what's limiting? All right, so if I've got 0.2 moles here, the ratio is 2 to 1, I need at least 0.4 mole here, and I've got more than that, so that one's in excess. This one is limiting. So remember the ratio is now 1 to 2, 2 to 1 to 2. So I'm going to be able to produce, so I've got 0.2 moles, I'm going to be able to produce 0.4 moles of calcium oxide. Okay, have a go at the rest of these. All right, when you've had a go at these, rejoin the meeting and we'll try talking through them together in our meeting. And then I have got a second video which is again slightly more complicated, which is the second set of questions I sent you, limiting reagents 2. Okay, so come back to the meeting now, we'll discuss limiting reagents 1, then we'll go on to talk about limiting reagents 2.